Thank you, Manuel, for coming here today. And Manuel is going to talk to us about the new project, which is the API Framework.
Yes.
And this is going to be a sneak peek of the framework because it's just very fresh out there. So
that's true.
the floor is yours.
Okay, hi. Then let me shortly introduce myself. I'm Manuel. I'm with Vector Informatik. And yeah, I know it's late, but I would like to introduce a new project here in Eclipse SDV titled Eclipse Automotive API Framework. We just started and we are close to our first contributions. Our first uploads are in the pipeline, and today I would like to use the chance to shortly present that to you. I have 4 topics or 4 slides I want to present today, starting with a short introduction. Why did we come together for this project? What is the idea behind it? Then a short primer on the idea of an application framework. We have seen it on a previous presentation already. Some thoughts about that. Then the Automotive API Framework. What's the content of this project? What do we have in the pipeline? And when will it be available to the community? And last, commitment of Vector. So I'm with Vector. I also want to present shortly, at least, what's the motivation for us to do this project? What do we plan here? So let me start with a short introduction. Main drivers of this project and initiators are ZF Friedrichshafen and Vector Informatik. And we started with a project roughly 1.5 years ago and had some discussions about development and integration on microprocessors. So we are now on the embedded level again. We are looking into ECUs based on microprocessors. And we see here, if we have a look on the stack architecture, we see there, from bottom to top, microprocessor, often some hypervisors, and POSIX operating system layer. On top of that, we have, at least state of today, basic software suppliers that bring in their communication or middleware stacks, for example, based on AUTOSAR, but we also see here other solutions as well. We also have heard about the S-Core project, also, I would say, covering that level. On top, we see the application level either covered by tier 1s, so traditional suppliers, but in the meanwhile, more and more the automotive in-house teams start to come in with own development here as well. And here we see, or I would like to differentiate between 3 types of applications. We have the ones based on AUTOSAR Adaptive. This is where we find a model-driven development flow, starting with some architecture, you know, all those RXML files, then based on that, some code generation. You get equipped with some proxy and skeletons, the ARA API, and the developer can start to develop based on that. In the end, you get the code base and you can build it to get your binary executables. Then we see also from the discussion with ZF that a lot of players in the field are working with other model-driven development flows, for example, based on solutions like MATLAB Simulink. They start with modeling in UML. They have also graphical modeling and development and test of their software. So we have the developers starting with some graphical tools. From there, they generate code, and then same workflow again. They build it together. They have their binary executables. Last part is plain C++ app. So we have also seen people walking around here with code first shirts. So this is, I would say, also the spirit here in open source. You want easy access to do applications. Ideally, and here I have one target group in mind, people joining the automotive industry from university or from other fields. They have a hard entry time learning all the automotive terms and patterns we have there. So when it comes to C++ apps here, they are seeking for something that is free of this, this burden, let's say. And ideally, IDE support to make your life easy. And here we see develop, you start with code, and then you have the packages. what problems can be identified on those 3 levels? So I have written a little bit of text, so you can read it later if you want. Let me shortly summarize. So we see when it comes to the AUTOSAR applications, problems that result from this model-centric approach. It's really difficult to collaborate between different teams, between the architects and the developers. We have long feedback loops. We have processes in the companies. And then we see when it comes to serious projects and to the end of those, we have integration and to really cumbersome integration and speed bumps kind of that often are difficult when it comes to agreed start of production dates. For the second part, for the ADAS applications and this model-driven development. So here, when we take MATLAB Simulink as an example, you cannot easily migrate. You have developed stuff there, then you are locked in. It's not easy to kind of bring the algorithms you have in there to a different environment. So that's one problem. And we also see that especially suppliers that based development on those tools and workflows have really hard times in the meanwhile, especially on the microprocessor platform, to come up with some idea they call software as a product. So they do not know from the beginning what middleware, what layer the OEM later on will have on their system. So missing piece kind of here. And for the last portion, we see a lot of terminology. We have specific APIs in the automotive field, but we see a lot of patterns popping up every time again. So we have communication patterns in distributed applications, but a lot of different terms and APIs to work with it, to use it. And that's just confusing for people to join the automotive field. And last point here on my list, at least as far as I'm concerned, there is no framework available out there which makes it easy for people to start, which also shows a migration path to automotive series projects. So in sum, we have a hard time when it comes to integration. Reuse is complicated, and we have a huge set of terms and definitions out there. And my understanding here, especially the term application, is a good example. Even here, the definitions differ. It's unclear depending on what kind of application box you choose. And that's a problem. And this brings me to the concept and the idea of an application framework. So we see here again this stack, what we kind of propose and what's content of this project proposal is to introduce a new layer that covers for the microprocessor stack, so for in-vehicle use, design, implementation, and test of applications, covering all the different types. So you can think of it on a really high level as a thin, modeled, and generated layer, but also, and that's important to state, it's not only this generated bunch of code, it's a complete workflow, including a tool that allows to work and to configure this particular layer in the microprocessor stack. The whole solution applies at compile time, and the focus of it is on the executable. So let me build up the solution. So we have this workflow starting in the real beginning with project initialization. You get equipped with a project environment. It already includes all the necessary files you need for build environment, for testing, etc. And then we have a foundation layer, a lean data model with packages for agnostic parts, but also for middleware related aspects. What that means, we will see in a second. On top of that, we don't want people to do modeling, I don't know, in a XML file or in a JSON file. We propose to have configuration as code. And how does that work? So config as code in the sense we use it here, it's a model abstraction of this data model we have here in the foundation layer. And this allows, we have a prototype in Python available to do the configuration of this layer in code. So you do Python coding, and that's the user front end to configure that layer. We have different types of importers in this concept that allow to import from all the IDLs you find out there. So IDLs, catalogs, whatever you want. So in this project initial package, we have put a focus on VSS, but it's just one example. If you work with other IDLs, other description formats, it's open and it can be extended. That's also one reason why we are here in the community, because we think that's a good example where input from, depending on your needs, will help. From this configuration as code, so from this Python code snippets, we produce a kind of a model database, which reflects the elements we have in our data model, but it's just an exchange format. This is not supposed to be edited. This is something, as I wrote here, a database that you can use to read maybe, but most foremost, it's used for our generators to create this thin layer. And what do we produce? We have an API for communication, but it can be extended to other use cases like persistency, for example. We provide code for testing, unit tests, for example, but also CMake or Basel files, like for the build environment. As I wrote in the top here, focus is on the production of an executable or more of them. We have user library aspects covering runtime, like starting of the executable, representing the programming model behind all that, for logging, error, and state handling, all the stuff that you will have to deal with as a programmer on the level of an executable. Now, let me show what that means actually when we look on such an executable. That's what we see today when we work with AUTOSAR. You get created from there some middleware interfaces. Not limited to AUTOSAR. If you work with a DDS-based solution, it's the DDS API you face here. Now, we have two aspects. We have static code in form of libraries, and we have the generated code from this workflow that fills up the executable to quite some extent. So we have on the right-hand side this control module that covers runtime, starting the executable, all this kind of boilerplate you need in the executable and you don't want to rewrite all the time. Then we have middleware abstraction in here, which is abstracting the lower layer, which is abstracting the different type of middleware solutions we have in there. And the intention for it is to make a unique and view and API available for the application developer, because those blue boxes here, we term them application modules. This is where the actual business logic lives. This is where your algorithm goes. You don't want to care about how the middleware functions and what kind of API you have there. You want to focus on those blue boxes. And that's why we have a shared domain between the framework and the developer. The red box is generated. That's an implementation stub you get provided with, so implementation and test stub, and you can now focus on the blue box. And this brings me to a point I mentioned earlier. So the term application in this framework is clearly defined. For us, it's a thematic bracket. So application is something that's, I don't know, an ADAS application or whatever you want to take. But on technical level, we have a clear understanding and a clear definition of it. It's 1 to n executables, and each of those executables can consist of 1 to m application modules. This brings me to the initial publication or the initial version that we bring to this project. So it's 4 building blocks. I took an excerpt from our project proposal. Don't want to read it out loud, but we have the foundation level, this model. And we said, or as I said earlier, we identified that all the different solutions, especially when it comes to communication, pick over and over again the same basic principles. And it's, from our point of view, pub/sub messaging and remote procedure calls that you need to do applications on the HPC. And we have, in a generic way, named them data elements and operations to avoid any automotive specific terms that are already used in AUTOSAR, for example. The initial focus of the project is communication, but it's not limited to it. So we need to start with something and it can be extended for sure. Then second building block is the specification of this API in C++. Then we have different types of formats supported. We have this config as code user-facing tool based on Python. We have those importers and exporters, an excellent possibility to contribute to the project. So as I wrote here, future editions are highly welcome. And as fourth building block, we have generators that can be used to produce not only the thin layer, but also the project artifacts like build environment, testing. So we based unit tests on Google Test, for example. Now, to visualize it again, this bundle that we almost completed and we will upload from Vector side by end of Q1, so in the next 2 weeks roughly, will allow you to do the following. So it's just illustrating the same image from the previous slide again. And you see here, we have this control module in place. Then we have, as one example, middleware, which we can easily integrate into an open source solution because it's open source as well. It's the so-called SIL-Kit. Maybe you have heard of it, maybe not. So it's just one example of a middleware solution you can put there. You can think of this middleware abstraction to be available for other stacks and solutions as well. And here you see also that here on this level, you have the lower layer specific API. And here towards the application module, you have the abstract API as described by points 1 and 2. And this, to make it concrete, we introduce a data model, this configuration as code solution based on Python. We have an importer included for VSS, user library for execution states, logging and error handling. That's not perfect, that's clear. So it's a lightweight control module we bring in for the beginning, but this is something where also the community then can collaborate on. We have generators included. When it comes to data types, we based it on the standard library types. For unit tests, we have Google Test Stub and mock generation. And for the platform modules here, as I said, the example we can include in the Eclipse project is based on SIL-Kit. And tooling, that's very important to state. So the complete workflow is backed by a CLI tool that makes the whole solution ready for CI usage. And we have different types of projects that allow to deal with different types of steps in the workflow easily. Here are the links to the project page. So I think I'm already running out of time a bit. I have one last slide if you're interested. So the plans of Vector, just shortly. So that's the gray box, Eclipse SDV bundle. This is what I just presented. What we have in mind to bring also, because you know maybe from Vector, we have also a microprocessor adaptive solution, so an adaptive AUTOSAR stack in place. We plan to have a community bundle also available for non-commercial use, where the SIL-Kit that is part of the Eclipse will be replaced, if you wish so, with a microprocessor adaptive abstraction module. This cannot become open source. That's why we do it in a different bundle. And finally, if there is interest from customer side, for sure we can also, without any concrete date, think of a microprocessor edition, so a product version of it to, if request is available, we can also bring this into kind of serious projects and extend it to customer requests. Thank you. That's it.
Thank you, Manuel. So we might have time for one very quick question. Okay. So if it is quick.
Yeah, so maybe one last comment. So we can meet later. What I also can offer, I'm also here tomorrow. I have also a live demonstration with me if you want to see it in practice.
Yes.
So I don't know, we can.
Let's defer this to tomorrow then, because So that's actually the nice thing of the open collaboration, which we want to do tomorrow.
Reach out to me. I have it on my laptop, then we can have a look.
Okay.
Yeah, willing to share
Fantastic.
that. Yeah.
Thank you very much, Manuel.
Thank you.
Thank you.